for the first part of section 6.4 graphs of polar inflation. If I can have some volunteer, please read the introduction paragraph. Thank you, Gaston.
The Americas Cup is the supreme event in ocean sailing. Competition is fierce and the costs are huge. Competitors look to mathematics to provide the critical innovation that can make the difference between winning and losing. In this section's exercise set, you will see how graphs of polar equations play a role in sailing faster using mathematics.
Okay, thank you. So when you guys are rich and you can buy your own sailboat, maybe you could use polar equations, right? All right. So my video that I actually recorded last year, I started recording on the third slide for some reason. So I want to cover this one with you guys. And so what we're going to do is the independent variable right here is theta, okay? Kind of like when you are talking about rectangular coordinates, x is the independent. In this case, theta will be the independent. I thought so too. And so now the dependent one will be r. So in this case, r is equal to 4 times the cosine of 0 radians. And so what is the cosine of 0? What is the x-coordinate there? 1. So this is actually 4 times 1. So the point that we need is, for r is 4, and for theta is 0. So we plot that point, 0 radians, and then the radius is 4. That's the point. Next one will be r is equal to 4 times the cosine of pi over 6. Remember, pi over 6 is like 30 degrees. So what is the cosine of pi over 6? Square root of 3 over 2. So that will give me 4 divided by 2 gives me 2, right? So that will be 2 times the square root of 2. Square root of 3. Comma, and then theta is pi over 6. So then I'm going to go ahead and plot that point here. So pi over 6. And can someone do on the calculator, give me an approximation of 2 times the square root of 3? 6? 3.5. Thank you. So that will be 1, 2, 3, and then 0.5. So right here. Okay, so let's continue. R equals 4 times the cosine. Now our independent is pi over 3. Let's take notes. Gabriel. So that's 4 times. What is the cosine of pi over 3? 1/2. So 4 times 1/2 is 2. So this will be 2 comma pi over 3. So let's see. We find pi over 3 and the radius 2. 1, 2. Okay. Then we have r equals 4 times the cosine of pi over 2. And so that will be, what is the cosine of pi over 2? Right here. What is the x-coordinates here? 0. So in this case, the point will be 0 comma pi over 2. So we locate the angle pi over 2, and the radius is 0. So it will be here at the pole. Then we move on. So we have r is equal to 4 times the cosine of 2 pi over 3. And that will be 4 times. What is the cosine of 2 pi over 3, guys? Not 0. 1/2. Remember, pi over 3 is right here. I'm sorry, 2 pi over 3. So it will be the same as this one, but negative. Okay. Negative square root of 3 over 2. And so 4 divided by 2 is 2. So that will be 2 times, negative 2 times the square root of 3, comma, 2 pi over 3. What do you say that was, Siriani? 3.5?
Yeah.
Okay, so we locate the angle 2 pi over 3, and then the radius is 3.
Wouldn't it be negative?
Hold on, I feel like I'm doing something wrong.
Yeah.
Okay, 2 pi over 3 and then 3.5 right here.
It's
Yes.
it's supposed to be negative 2 and then 2 pi over.
Right here?
Yes.
So we did this wrong?
Yes.
Okay. So this should have been negative 1/2.
Yes.
Okay, so negative 1/2. So then 4 times negative 1/2, that would be negative 2. All right. So do you guys recall how we plot when the radius is negative? What do? If the point won't be here at positive 2 for the radius, it's negative 2, so what do I need to do?
I'll do the opposite.
The opposite way, right here. Okay, we're almost done. Now we have r equals 4 cosine of 5 pi over 6. So that is going to be 4 times the square root of 3 over 2, but negative, correct? So then that will be negative 2 times the square root of 3, comma, 5 pi over 6. So on the graph, we find 5 pi over 6 as an angle, which happens to be, oops, right here. Then the radius will be approximately 3.5, but it happens to be negative, so the point will be there. It will be opposite to that. So 1, 2, 3.5, so right here. Okay, and one more point to plot. That will be for pi. So r equals 4 times the cosine of pi. What is the cosine of pi? The x-coordinate number. Not 1. Negative 1. So this is 4 times negative 1, which will give us the point negative 4 comma pi. Okay, so we locate the angle pi, which is here, but since the radius is negative 4, the point won't be here. It will be here, right? All right, now I'm going to connect them, and it looks a little bit weird. It's actually just going to be a circle. And they do have a name. Oh, they're just circles. That's their name. Okay, so this is the end of the video for section 6.3, part 1.